All right, so welcome back. Today we're going to finish up our discussion on arrays, and at least in Java, we're going to finish up our discussion on, yeah, I transitioned, there we go. Okay, I was just checking my audio. Remember that we are on Piazza for live Q&A. If you've got questions, make sure to post them on the live Q&A session that I just created. But otherwise, today we're going to finish out arrays. On Thursday, we will. I'll present some tooling, meaning that like tomorrow, if you do the C version, you're going to use a tool called Valgrind, where you can detect memory leaks, potential memory leaks, as well as other things like segmentation faults. Why did this happen? Well, it'll tell you that there was you access something out of the bounds of an array or something like that. Valgrind can actually run the program, simulate it, and tell you exactly what happened wrong. Another tool that we'll cover is a debugger. For C, we'll be using GDB, and for Java, we'll just be using the built-in debugger that comes with Eclipse. Okay? But to complete what we started last time, we talked about we started talking about arrays in Java, and of course you can use them just by new array. You don't have to have malloc. Instead, you have the new keyword. You don't have to clean up after yourself because Java is memory managed. It has a garbage collector that takes care of all that for you. But Java is a programming language that provides much better data structures than just plain old arrays. So if you have the opportunity and to make a choice, definitely make the choice of using one of these data structures. We looked at lists. Lists are ordered. They basically can grow dynamically or shrink dynamically as you add stuff to them, as you remove stuff. We gave, and it's parameterized so that you can have a list for integers, you could have a list for doubles, you could have a list for strings, you could have a list for anything. You create it using an array list, an array-based list. You can add stuff, you can remove stuff, you can add stuff to an arbitrary index, and everything will be moved so that you can put it'll accommodate that new element in there. You can print stuff out. You can add stuff, etc. We left off with looking at sets. The difference here is that sets are unique elements. So if I try to add 10 twice right here, then there's no difference. And so I've got that simulation still over here, or that code block still over here, that you'll have 10, 20, and 30. And another thing about sets is that they are unordered, right? Even though I added it 10, 20, and 30, that's not necessarily the order that you have. There's no concept of the first element. There's no concept of the second element. If I tried to do that like I did with a list, s.get the element at the 0th index, there's no such method, right? The method getInt is undefined for a set because you can't get the first element. There is no first element. It's unordered. So one immediate question is, well, how would I iterate over the elements of a set to say print them out or process them or sum them up, right? We have what's called an enhanced for loop, which I briefly probably discussed at the very beginning of the semester. You don't use the keyword for each. Some languages do have the keyword for each. Java does not. But it is basically a for each loop. For each element in the set S. So for each integer x in the set S. That's how you should read this. So for each integer x in the set S, ... Just go ahead and print it out or something. System.out.println x. X is a variable that gets updated on each iteration of this enhanced for loop. Just like with the traditional for loop, if you wanted to iterate over a list, for I equals 0, I is less than n, I plus plus, right? You get the first element, 0, second element, third element, fourth element, etc. And you can get that element and print it out. This one, it automatically updates for you, right? It's syntactic sugar. It's an enhanced for loop, it's a for each loop, basically, right? We can see this in action. And we got 20, or 10, and 30 out of that. Yeah?
Why that order specifically?
That's what it decided was the best order. Underneath the hood here, there is a hash table. And hashing means that it uses the object to determine, there is an array sitting somewhere under the hood. And it does store stuff in an array at some point. But where it stores it is determined by a hash function. That it takes the object and it says, okay, well, I'll produce an integer through a very simple function. That integer could be 2. All right, I'll put it in at location 2. Another one that is completely different, might come before, might come after, it doesn't matter. The hash value might come before or might come after. It depends, right? That's all opaque to us. We don't want to have to know about those details. We just know that there's this set that we can interact with. So if you need duplicates, if you need 2 10s in there, you're not going to be shopping for a set. You're going to be shopping for a list. If you need order, you're a list. But if you want uniqueness and you don't care about order, then a set is the way to go. By the way, an enhanced for loop works for all collections. I could use the same syntax here on a set, instead of the set S, the list that I had before. Right? But I'll go ahead and keep this and put it in the notes for you so that you have it. Okay? Oops. There we go. Now, if you think lists, I'll just take a small poll here. Lists and sets better than just plain old arrays? Yes? Votes? Okay, hopefully. Well, I'm going to give you something even more powerful called a map. Right? So lists and arrays are limited in that they only map integer values 0 through n-1 to other values. Right? At least with a list is dynamic. It can grow, shrink as needed, but it is still limited in by its indexing. Right? The indexing of 0 through n-1. I want to free myself from that. A map is a key value pair data structure. Right? It stores elements, which are values, using any arbitrary key, right? Which can be any object. So you're no longer limited to integers 0 through n-1. Now you're free to do whatever you want. So for example, let me come over here and start out with a very simple map. I'm actually going to provide 2 parameterizations here. Let's go ahead and map integers to strings. Right? And I'll call this my map. Equals new hash map. Elide those away. Remember that word from last week, that 50-cent word, elision or eliding. Taking away unnecessary things. Right? There we go. Come on. Why are you not? Okay. I don't know why it didn't import that, but let's go ahead and just do it manually. There we go. Now you're okay with it. What this is basically saying is this is a collection that holds stuff, and it maps integers, not necessarily 0 through n-1, but arbitrary integers, to strings. Right? Now, instead of adding stuff to my map, I'm putting stuff into the map. My map.put, I'll map my NUID 35140602 to my name, Chris. Right? There we go. I am mapping this arbitrary integer to, well, this arbitrary string right here. I can put as many things as I want in there. I can put 1, 2, 3, 4, 5, 6, 7, 8 to Joe, my map dot put 8765432 to Jill. Right? So I've got 3 people in here. Right? I am mapping NUIDs essentially to names. So if you want to, you can give this a more descriptive name now. NUID to name. Right? I'm not going to ask you for your NUIDs. Oh, darn it. Now I'm going to have to cut and paste 3 times if I wanted a different name. Do I have to cut and paste 3 times? Or if this was like a 100 or 1,000 line program, do I have to cut and paste 1,000 times? Nope. What can I do? Here's the trick again. Right click, refactor, rename. I've done them all. Right? Cool. All right. Oh, and then no parenthesis on Jill. Right? Okay. Great. How do I interact with this thing now? Well, I can always get stuff out, so get stuff out. Again, these are keys, and as long as I've got the key, I put the key into the slot, turn it, and it will give me the name back out. So I'm expecting a string to come out of this map. String name is equal to nuid.get. Now here I do get things. 35140602. That should get my name, Chris, out of that. System.out.println name. And you'll see that, in fact, it works. Right? There's Chris. Right? What about getting something that doesn't exist? 10. Right? Or who? There we go. Who has the NUID 10? Anybody? Oh, do you do? Okay, really? Probably not. I've seen NUIDs that begin with 2 zeros, but certainly not 6 zeros. I don't know if that's a thing or not. I would imagine that they've reserved certain formatted NUIDs for administrative stuff and debugging and stuff like that, right?
Yeah, I'm actually a professor.
So, no, it's definitely not mine. But that is my real NUID. You can, it's not associated with any account, so you can go ahead and try to do whatever you want with it. You should protect your NUID, because I ran a crypto course several years ago, and as part of that cryptography and security course several years ago, and one team decided to, as their project, to hack N cards. And they are actually very successful and very easily done. They bought a card reader, which is pretty cheap. I think they paid $30 for it from China or something. And they were able to reverse engineer how NUIDs were stored on a card. And all they needed, they didn't exactly reverse engineer all the other data on it, but they did get to a point where they could have at least flashed a new card, as long as they got a card writer, an RFID writer. That would have been another $100, and so they didn't want to go all that way. But they very easily could have at least flashed an RFID card so that they could, go up to a vending machine or whatever on somebody else's account, and now the pops are on you instead. Yeah.
What did the teachers think of that assignment?
I would give him an A. I was the teacher, so good job. That's exactly what I wanted them to do. As long as they weren't malicious, then another team sniffed passwords going across using Wireshark. All these things are very easy to do. Now, some things you can get caught on. I demonstrated how to do not DNS spoofing, but basically. I practiced at home on my wife's Kindle. Basically, you set up a man-in-the-middle attack where you send out, not DNS spoofing, it's something else. But I forget what it was at the time, but basically you can say, hey, Kindle, don't send your traffic to the router. Send it to me, and then I'll send it on to the router. Hey, router, don't send your traffic to the Kindle. Send it to me, then I'll send it on to the Kindle. And then everything's going through you. Of course, you can see everything, and you can modify anything. And it's actually really easy to do, but it is detectable on a network like UNL where they're monitoring for things like that. So you do have to be careful in some ways. But in any case, back to the simple programming of basic maps. What happens when you ask for somebody that doesn't exist? You get null. And so you can check for that. It doesn't crash, it doesn't throw an exception, it just says, there's nobody by that NUID here, here's null as a signal, right? You can replace stuff. For example, if I want to change my name to Christopher, my full name, right? And get that out again, and print it, right? You'll see that the old value was changed, right? So you can replace stuff by simply just rewriting what the key maps to, okay? How might you iterate over all these things to print them out or to process every single thing? Well, it's unordered, just like a set, so you have to use an enhanced for loop, right? So iterate. For. Now, there are two things here. There is a key mapping to a value. So there are a couple of ways that you can do this, but the easiest way is to iterate over the key set. Give me the set of all keys. In this case, the keys are integers. So just like last time, for integer key in the collection, what is it, NUID to name dot key set, this gives you a new set containing all of the keys in the map. Once I've got the key, of course, I can get the value using the same syntax up here, and string value is equal to NUID to name of the key, and then I can print them back out, all of them out at once. System.out.println key maps to value. NUID to name. Why are you complaining? Oh, .get. Sorry, there we go. And we can see that I've got all three of those values printed. My NUID goes to Christopher. This one went to Joe. That one went to Jill. Don't read anything into the order here. Generally, they're unordered. You can get a linked hash map that does preserve an ordering, but that goes beyond what I'm going to present here. So that's integers, arbitrary integers though, mapping to strings. You can do the reverse as well. You can have a string mapped to an integer. Right? Numbers is equal to new hash map. Right? And I can put stuff in here like numbers dot put ten, I'll map that to 10. Numbers dot put 100, I can map that to 100, right? And I can I'm not going to show much more here, but what I want to emphasize here is that you're mapping strings to numbers. You can map strings to strings. You can map an arbitrary object to any other arbitrary object. That's the beauty of maps. Right? You're no longer constrained by zero indexing anymore. Right? So, questions on that? I'm sure that you can start now thinking of use cases for this stuff very, very easily, right? That if you start using a smart data structure, all of your code becomes extremely simple, right? In fact, in Computer Science 2, next semester, we'll be making an announcement about that soon on how to register. You still have a month before registration starts, so don't worry about it. In Computer Science 2, I quote Eric S. Raymond, who one of his mantras for software development, for software engineering, whatever you want to call it, is smart data structures and dumb code are a lot better than the other way around. Dumb code, you're doing a lot of manual work, and you're not leveraging any data structures. You might be leveraging plain old arrays, right? But with smart data structures, you're letting the data structures do the heavy lifting for you. Let the map do its work, right? Let the map do all the heavy lifting of, I need this thing, okay, well, map, give it to me, right? And the map gives it to you automatically. You don't have to go through the entire array to find the thing that you're looking for, as long as you are maintaining that key value pair relationship, right? So let data structures, smart data structures, do the heavy lifting for you. You might ask yourself, well, that seems really, really useful. Why isn't that in C? It is. You just have to bring in a library to do it. It's not part of the standard C library. There is a hash table in the standard C library. Don't use it. It's terrible. That's terribly designed, in my opinion. But over here in Java, these collections, well, they're so beautiful. I use them. Right? Not only that, but if you look at the documentation, there are dozens and dozens or hundreds of methods that you can use on them so that you don't have to reinvent the wheel. Right? You'll find that in assignment 4, when you start using arrays and lists in Java, you'll find that, the complicated stuff that took you 20 or 30 lines of code in C is a one-liner in Java because it's already taken care of for you. Right? And I'll show you another example here in a second. Right? But before we do that, let's talk about multidimensional arrays. Right? So in both languages, both languages support multi-dimensional arrays, right? 1D arrays are just regular arrays. Regular old arrays. The ones that you've been using so far. You can also have 2D arrays. So what does 2 dimensions look like? Well, if 1 dimension looks like a row, then what does 2 dimensions look like? A square or a rectangle if it's not perfectly square. You can have, 3 columns and then 10 rows, right? You can have 10 columns and 3 rows, right? So what is that thing? What would you call it? 2D. What's another name for this thing? A what? A plane, okay. So what you have rows and columns, right? In other words, i.e. a table, or think math. Matrices, right? There we go. You can go 3 plus dimensions, but rethink it. And I'm not going to cover them. You can go into 3 dimensions, just like we call them rows, columns, and, well, if you go to a grocery store, what do you walk down? Aisles, right? Why? Because you look at the cereal and you've got rows of cereal, you've got columns of brands or whatever, and then your 3rd dimension is that you walk down the aisle. So you've got rows, columns, and aisles in that case. 4 dimensions, then we're not 4-dimensional beings, so we lose whatever concept we have of mapping that stuff out, right? But in any case, 3 dimensions and above, no, rethink what you're doing. There's probably a better solution somehow. So what about Java? How do you do this in Java? Well, if you're going to go with a 2-dimensional array, then yeah, okay, go ahead and go with array. You can do a list of lists. I've seen that before, but that looks icky. In any case, what you can do with Java is really, really simple with arrays. I'll call it a matrix, and it's 2 dimensions because I give it 2 square bracket notations, right? And I can say that it's this a new matrix of size, I don't know, n and m, where n and m are just going to be arbitrary integers. Int n is equal to 2, m is equal to 3, say. So now this is a 2 by 3 matrix. That is, in other words, 2 rows, 3 columns. Right. And it's all set up for me. By default, all values will be 0. By default, all values will be 0, right? But you can use 2 indices to access or set. Right? So what does that look like? Well, matrix of, what's the one on the first row, first column? What indices is that going to be so that I can set it equal to 42? First row is going to be 0 indexing. 0 indexing everywhere, remember. First column is also going to be 0 indexed. If it's a 2 by 3 dimensional matrix, then what about the lower right element? Lower right element. Where is that going to be? I'll set that equal to 21. It's going to be, so it was 2 by 3, so the second row is going to be 1. Oops. And the last column is going to be 0, 1, 2. Right. Going beyond that, of course, will result in an index out of bounds exception. Okay. You can also you can get the length. Matrix dot length is excuse me. Int num rows is equal to matrix dot length. Int num columns. Well, I have to get the first row and ask how many columns are in that row. So matrix, so 0 dot length. Now you can, the way that I've showed you, every row will have the exact same number of elements. You don't have to necessarily do that. You could go through and the first row could have 10 elements, the second row could have 5, the third one could have 8 for some reason. You would go through a for loop in order to do that, but there's really no point. All of our stuff is going to be square or rectangular, right? That's just weird, right? Question? It's called row major form. Row major form. That the row then column. Right? So don't think about it as X, Y. That might help if you're ever thinking about it like on a grid, like on a plane grid. Then yeah, they're going to be transposed there. But since this is representing a matrix, we go in row major form, which the row comes first, and then the column. Now, it really doesn't matter to a computer because take the computer and turn it upside down. It's just storage in memory. So if you want to, you can go in column major form where you treat the first one as a column and the second one as a row. But you just have to be consistent about it. Okay? No cleanup because Java, of course, is garbage collected. So we don't have to do anything on that front. But what about in C? Right? In C, a 2D array needs 2 pointers. Right? Int star star matrix. Why two? Oh, sorry. There we go. Why two stars? Well, because what it's going to end up being is the first pointer is a pointer to an array of pointers. Right? Then each pointer in the array is a pointer to a row of integers. And that's how we end up doing this. So let me go ahead and give you the code right off the bat here. And we'll take a look at a visualization of it and walk through it. I don't want 10 and 20. Let's be consistent and go with 2 and 3. Just because I don't want 200. How many things would be 10 by 20? 200, and I don't want that many. So let's walk through this step by step. I've got my matrix here, which is a 2-dimensional array of integers. When I call malloc, I need to cast that appropriately. This is an integer pointer, so therefore I need to make this into an integer pointer. How many of them you want? Well, I want n rows. How many bytes does an integer pointer take? Not size of int star. Right? And it is different because typically an integer is 4 bytes, but an integer pointer is typically 8 bytes on a 64-bit system, or with memory addressable at 64 bits. Yeah?
What's the use of pointing to an integer pointer if that integer pointer is just going to point to...
Because I'm pointing to an array of pointers. Each pointer points to a row of integers. So there are alternative ways of doing this. But basically, if you're interested in those, I present in the book 2 other ways of doing this, and also in the videos in C of 2 different ways of doing this. But the way that I'm showing right now is a visualization that we'll look at here in a second. Python tutor. We'll take a look at this after I've gone through the rest of the lines here. So this is actually, let me cut and paste this and start it immediately so that because it's going to take maybe a good 10 seconds here to warm up. But in any case, I need an array of integer pointers because each pointer is going to point to a row. I need to go through a loop. On the first iteration, I set up the first row. On the second iteration, I set up the second row. On the third iteration, I set up the third row, right? And each one of those calls is simply just a call to malloc that we're used to. M times size of int. So let's watch it as we go through here. So I've got n and 2 and 3. By setting up the first one, this is an array of pointers now. Right? Then on the first iteration of this for loop, the first pointer sets up the first row of 3 elements because it's 2 by 3. The second iteration sets up the second pointer, and that's the second row of 3 elements. So this up here is not the matrix. Down here, each one of these rows is the matrix. But after that's done, I can access it just like I would a normal 2D array. What I can do after that is I can go, there's a matrix. So in fact, I'm just going to steal the code from above. It's exactly the same code. The one at the top left is 0, 0. The one at the bottom right is 1, 2. And the way that works is if you want the 0th element, then it jumps to this pointer, jumps to this row, and if you want the first element, then that's going to be 0 right there, 0, 0. If you want the one at the bottom right, this one right here, then that's going to be 1, 2. Basically, it jumps to this pointer, index 1, then it jumps to that array, and then it jumps over to index 2. And that's how it gets this element right here. Yeah?
So say you wanted to make like a periodic table kind of thing. Make a matrix.
It's a table, so yeah.
But then you would make a map. Like it wouldn't be a physical table, obviously, but it would be more like a matrix. And then you could even take like a map to where each number value that you would assign to each.
You could, but in C there are no maps. The map is your row and column index value. So in that sense, that pair, I and J, right, then is your map. And of course you can do that, right? For int I equals 0, I is less than n, I plus plus. For int j equals 0, j is less than m, be careful because it's an n by m dimensional matrix, and don't get those mixed up. And don't get your i's and j's mixed up. Printf, %d, space, matrix sub I, j, right? And then I can make that look pretty by putting an end line after we're done with everything. I won't use this visualization here. I'll just go ahead and cut and paste it here. Save, GCC demo. Oops. Where am I? Code, GCC demo. There we go. There. 42 at the top, 0, 0, 0, 0, 21 at the bottom right. That's because of these two lines right here. Don't read anything into the zeros here because in C, there is no default value. This is just a particular compiler and a particular operating system quirk that's setting the default values to 0. Okay? All right. What about cleaning up? Cleaning up, ... Well, what function did we use to clean up our memory in C? We gave it back. We freed it, matrix. Let's find out what happens when we do that with the visualization tool. Free the matrix. Who knows what other mundane mathematical thing will be turned into another blockbuster movie and then have a different meaning in the zeitgeist, right? Of course, I'm referring to the Matrix movie, right? Up until that movie, if you said Matrix, people would say, "What the heck are you talking about?" Unless they were mathematicians, right? Just like I kind of skipped it, but so first dimension, if I've got first dimension is going to be, of course, a line. Second dimension can be a square. Third dimension is going to be a cube, right? And if I take that cube and I take it up to the fourth dimension, what do I have then? Oh, okay, I thought we knew it.
I was wondering if we, because I don't.
Well, Marvel movies, what is it called? The Tesseract, right? That's what a fourth dimensional cube is. So I thought that these things were popularized by Hollywood movies, right? Or in Interstellar, they talk about the Tesseract. And it's like, okay, I don't know how a Tesseract gets you time travel, but whatever, right? So there's the code, and I'm about to free up this matrix. What's going to actually be freed up, though? The matrix is referring to this array right here, right? What about these arrays down here? Well, visually, they're going to end up disappearing, but they're still in memory. They still belong to my program, but I've lost all references to them. What do I have here? What is that called? A memory leak, right? I've leaked out memory. That's memory that belongs to my program, but it's unusable. And when my program ends, of course, the operating system will take that memory back and then reuse it. But as long as my program is running, that memory is leaked. It's gone. I can't use it. So what's the solution? I need to work backwards. Clean up each row first, ... And to do that, Oh, you know what? I never copied all that stuff over. Or I lost it somehow. Well, in any case, here, I'll do it here. I'm going to clean it up first. So I'll go into my for loop here, and I will free each row. Well, the first row is at matrix of I. The second row is at matrix of 1, excuse me, then 2, then 3, then 4, right? So free up each row first. Free up each row first. Then free up the array of pointers. Right? And visualize this execution. I'll make sure that this is in the notes though, fully. There we go. There's a question or not? Well, we'll wait. No?
I don't understand the
Okay. Well, let's walk through it as it works. So I've got the setup there, right? What I need to do is I need to clean up all three of these things. If I clean this one up first, then the only way that I could get to this thing down here was through this pointer. But if that pointer has been deleted, then this row is leaked, right? I cannot clean that up anymore. Likewise, if this one is gone, then I can't clean this one up anymore. So what we're going to do instead is iterate through each pointer, clean this one up first, then clean this one up, then you can clean this all up here. So it deletes that first row. Then it deletes that second row. Only after those those arrays have been cleaned up, now I am free to clean up this matrix right here. And it's gone. Yeah.
But everything automatically cleans up when the program's done, right? This is only really becomes useful when there's just like long codes.
Well, long-running programs, yes. Think about a web browser. Like this has been open now for a good 37 minutes. If it had memory leaks, my program, my system would now be grinding to a halt, right? But fortunately, hopefully, it doesn't have that many memory leaks. You'll witness this tomorrow in your lab if you do the C version or the Java version, where we have an intentional memory leak. You let it run in the background, and then you run a utility called top to see it actually stealing more and more of the system memory. Eventually, you might reach the limit, the user limit, because they do put on a user limit. You can't have all the memory, and it'll eventually kill your program. But I think that it runs long enough that you can kill it manually yourself. Right? Okay. So that's two-dimensional matrices. The last concept with respect to arrays is deep versus what's called shallow copies. For that, I'm going to go ahead and go back over here to this visualization. Get rid of this. Right. Oops, come on. Get rid of it. There we go. Let's go ahead and create an array of 5 integers. Int n is equal to 5. Int star array. I'll just go with A here for shorthand. Int star malloc, a call to malloc. And how many of them you want? You want n of them. And how many bytes does each integer take? Size of int. And then I'll go ahead and initialize them for int I equals 0, I is less than n, I plus plus. I will set them equal to 10, 20, 30, 40, 50. So a sub I is equal to I plus 1 times 10. Right? And then you can see this visualization. But before we do that, let me go ahead and create another integer pointer, b. And I'm going to set it equal to a. Then I'm going to change a. The first one, instead of being 10 like it was before, will be set to 42. What effect will that have on b? Let's visualize this. So should B be changed? B was a copy of A, so it should have 10, 20, 30, 40, right? 50, right? But we changed A now to 42, 20, 30, 40, 50. Yeah. There we go. All right, so we run through this 10, 20, 30, 40, 50. On line 9, we make B equal to A. What is that going to do visually? This is a pointer, this is a pointer. It just means that it's going to end up pointing to the same thing. 2 pointers pointing to the same thing. So if I change A of 0 to 42, what does that do for B? It's also changed. This is what's known as a shallow copy, right? A shallow copy is simply when two references or pointers point to the same thing, right? Consequently, consequence is going to be, consequence is that changes to one affect both, right? So here's the example that I'll put in the notes for you, right? Again, this is a shallow copy, right? That changing A here will mean that you've changed B. Sometimes you don't want that. Sometimes you want two distinct copies. I want A to refer to 10, 20, 30, 40. I want B to refer to its own 10, 20, 30, 40, 50. So that if I change A, B is not changed. That's known as a deep copy, right? A deep copy is a completely different and distinct copy of the original, right? Changes to one do not affect the other. Right? Question?
So shallow copy is like traveling back in time and back to the future, whereas deep copies are more like traveling back in time and endgame, I guess.
I have no idea. I think that the analogy fails at that point, unfortunately. So what does it look like in Java? Well, of course, we don't have pointers. We only have arrays. And we don't have malloc, we have what? How do I create an array of 5 integers? I want a new integer array of size n, right, in this case. Otherwise, the for loop is exactly the same. I don't have pointers here, but I can do this, right? And when I do something like this, then I get the exact same behavior, system.out.println. If I print out what b sub 0 looks like, not O, 0, there we go, I'm going to get 42. Right? So I won't visualize this, I'll just prove to you that this is the exact same thing, right? And notice again here that it's almost a line-for-line translation between C and Java. Right? So why do we have so many programming languages, right? I agree. So here's the Java version, right? So how do we do deep copies? Deep copies, right? So in C, oh yeah, go ahead.
Could you make a note that that's the Java version?
Oh, sure. Java, there we go. Java version, there we go. So deep copies in C, you can simply just, you can copy manually, right? So what I mean by that is, let's go ahead and write a function to do it. Let's write a deep copy function that takes an integer array and the size of that array. Remember bookkeeping. If you're going to pass an array in C, then you also have to pass the size of the array because there's no way to tell how big of an array there is. So int star, that's the new array, deep copy. Right? What's it going to take? It's going to take an integer array and the size of the integer array. Right? And it's going to create a new one. Integer array copy is equal to int star call to malloc, right? Int times size of n, n times size of int, right? You're going to ultimately return that copy, but what you need to do is you need to go through, copy the first one, copy the second one, copy the third one, etc. So for int I equals 0, I is less than n, I plus plus, copy sub I is equal to array sub I. And you're returning this copy. So let's replace the shallow copy now with this deep copy of A. We'll set the first one equal to 42, visualize this execution, and we'll see that the copy of B, the deep copy of B, n, that's the size of the array. You'll see that the deep copy is not changed. It's still going to be 10, 20, 30, 40, 50. Wish this were faster. Ooh, they've got TypeScript, Ruby, and C++ too, if you're interested. Now, of course, Python was what they started with, and Java. So let's go ahead and run through this really quick, since we've seen it before. Execute. There's 10, 20, 30, 40, 50, right? Now we're going to make a call to deep copy. Deep copy is going to end up creating another distinct array, copying each element over, and now you see that there are actually two arrays. A and B are not going to be pointing to the same thing. When I return from this function, you'll see that A and B are now two distinct copies. If I change A to the first one to 42, B is not changed down here. Oh, wait a second though. Here's something I could do also. Copy, or not copy, but erase. Once I've copied it over, I'll go ahead and reset it to 0. Does that sound right? So here's the contract. I'm the deep copy function. You have an array that you want to copy. You want a deep copy of this thing. You give me the array and tell me how big it is. And I say, okay, I'll make a copy. Here's your copy. But I'm also going to screw up your original copy. Does that sound right? No. One way that you can prevent that is by making it into a const array, right? So let me go ahead and take all this code and bring it over to my CS50 IDE here, because I want to show you what the compiler will do when I try something like this instead of the visualization. There we go. Right. So exact same thing as before, deep copy, but again, I am changing your original array. Doesn't sound right. By making it const up here, I'm making it constant. I'm making it read only. Assignment of read-only location using that const is an error. You can't do that. Before, when I had no const, of course it was perfectly fine letting you do something like that. Right? Clear this out, GCC, and it'll run. Now I'm not printing anything out, so fine, but it's actually screwing up your original copy here. Right? But by putting const in front of it, I am giving you an advertisement. I am promising, right? I am promising I'm not going to screw up your data, because the compiler is going to enforce that. There are ways around it. Don't worry about those ways. Right? You can basically just create another pointer, shallow copy pointer, point to that thing, and then make a change through that pointer, and the compiler may not be able to detect that. Right? Yeah?
Would this be how copying saved data works in video games?
I mean, it certainly would be a deep copy, or overwriting the original. It depends on how many saves you have, right? If you have 10 save slots, then you want to save an 11th game, then you're going to have to overwrite something else. This is just a promise to the compiler that I'm not going to be doing things like this. Right? Once I take that out, of course, the compiler will now let it compile again, even because it's const. Okay, nope, you're not making any changes to it. You fulfilled your promise. Right? Let me go ahead and copy paste this. Right? Into the notes. There we go. And note that you can use the keyword const to prevent any changes to an array passed to a function. Right? There are ways that you can do it with a matrix. It's just going to be a lot more complicated. You need a const pointer to a const pointer. And at that point, forget about it. Right? We don't make you do that in the assignment. Anyway, okay? What about Java? How would I do this in Java? Okay, well, let me go over here. I'm going to cut and paste this deep copy, and let's try to translate it over here in Java. Well, first of all, I've got to have it public, static, and then not an integer pointer, but because we don't have pointers, but it'll return an integer array. Deep copy of an integer array. I don't need to pass the size here in Java because of .length. So int array. There we go. There's the original. I don't need to to do this, it's basically int copy is equal to new int array of array.length, right? Remember, n, you don't need to pass that because you have array.length, that property. And then you could do this. Instead of n, I need this length. Ah, man, I'm writing a lot of code here. I'm starting to sweat. Actually, I'm starting to sweat because I think they started to turn on the heat in these rooms. And I've got my hoodie on here, right? So, but I am starting to sweat because I'm writing too much code. There must be a better way. Right? But of course, this certainly will work. Instead of A, it'll be, what do I call it? Deep copy. Demo.deep copy of A. There we go. And now changes to B will not be seen. It'll still be 10. I don't have to write my own. Right? Instead, what could I have done? I could have RTM'd, read the manual. And there is an arrays dot, well, it's not going to show up for me because of my Eclipse is screwed up, but Java arrays. Right? Guess what you have here? Not that, not that. There we go. Find copy of. Right? So if you want, if you have an integer array, you have a copy of function to do this for you already. Here's the original array. Here's a new length. It's actually more general than just a deep copy. If you've got 1, 2, 3, 4, 5 here, and you want only a copy of the first 3 elements, you can pass in 3 and it'll only make a copy of the first 3 elements. If you want a copy of the original, all 5 of those elements, then you would pass in 5. If you want a copy as well as additional space, then pass in 10. And it'll copy the first 5 of them and then pad it out with zeros at the end. Right? And that's all in padding with zeros if necessary so that the copy is of the specified length. You have all of these things for booleans, bytes, chars, etc., and even objects. Right? So this is a generic object, any old object. If you've got an array of strings, if you've got an array of whatever, right? So it's much better to use that. Int b is equal to arrays dot copy of a, and then a's length there. Now I don't have to roll my own anymore. I don't have to write my own function to do this. There we go. What about lists, sets, maps? Lists, sets, and maps also have deep copy functionality. To demonstrate, let's go ahead and create a list here of, say, strings. A, no, I've already used A. So names is equal to new array list. And let's add some things to it. Chris, or dot add, sorry. There we go. Joe and Jane. There we go. And I can create a brand new copy of this list of strings. Copy of names is equal to new array list. Of course, I can go ahead and manually, for each element in the, do an enhanced for loop. For the first one, go ahead and add it to the copy. For the second one, go ahead and add it to the copy. Or I can just provide this right there. This is called a constructor. This is a constructor method that constructs a new array list. You can also give it another array list, or actually any other collection that you want. You can change a set into a list, and a list into a set. If I want a set of strings, copy, but a set, set instead, right? I'll just call it copy set, right, is equal to new hash set of the same thing, pass in names. I am going to change, I'm basically creating a brand new copy, completely distinct copy, but I'm changing a list into a set. You can change your set into a list. You can change the key set into a set or a list. You can change the value set in a map to a set or a list. You can do all sorts of things with these copy constructors here. Let me go ahead and print all of these out. System.out.println names. Make a change. Oh, let's make a change to names. System.out or names.add another Chris, but with a K. And let's print out names, copy of names, and copy set. Copy of names and copy set will not be changed. They will not have Chris with a K in them. There's Chris, Joe, Jane, and Chris. There's Chris, Joe, and Jane, the copy. Joe, Chris, and Jane. Well, why is it in a different order? Again, it's a set. Okay? So all of these things are really, really convenient if you just take some time to read the documentation, realize I don't have to write 20 or 30 lines of code. I don't have to debug it. I don't have to test it. I don't have to do anything to it. All I need to do is call this method over here that's already provided for me. Right? So you can spend 5 hours to write 30 lines of code, well, more like 1 hour to write 30 lines of code, another hour to debug it, another hour to test it, or you can say, take 20 minutes to read the documentation and realize there's probably something in there already for me. Yeah?
How do you do it to a map, or like to a map back? How does that work?
What would you want to do? What would you want to do with a map?
Didn't you say you could do it like the list or set to a map?
Okay, well, you can take the key set and dump it to a set of keys. We already did that, right? NUID.keyset. Right? The value set, let's just go ahead and grab all the values. So all the values like Chris, Joe, and Jane here. Let's go ahead and create a set of strings, the names from the map. Right? Terrible variable names here. This is just demonstrations though. A new hash set of string, not strings. And I can elide that. And I can pass in, say, NUID to name dot values. So I can get the key set or I can get the values. I think that returns a set, right? Yeah, it returns a collection. All of these things are collections. So it may return a set, it may return a list, I don't know. It's just a collection, right? And then I can print this out. I'll print out the names from the map. You can see that it'll be Chris, Joe, and Jill. Not necessarily in that order because, of course, this is a set. Right? Joe, Chris, and Jill, right? Instead of Jane. If you want a list instead, well, list and array list. Now, again, there's no guarantee on what order they'll be in, but that looks like the order that I put them in. That's just a coincidence. Okay? So questions on arrays and collections. Again, I really want to highlight the difference between the two languages here, that Java is much richer in terms of what it provides you in the standard libraries. And so, use that, right? Just take a few minutes to read the documentation. RTM, read the manual, or RTFM if you really want to, which is the actual acronym to really emphasize that you should read the manual, read the F manual. But that 20 minutes of investment of reading the manual to see, is this problem solved for me already, right? That's the whole reason we started writing functions to begin with. What's the first question you ask yourself when you're trying to solve a problem? Is this problem already solved, right? And is this problem already solved, right? Use those things. It's never cheating to use a built-in standard library function. Right? In the real world, it's never cheating to bring in a library, unless, of course, you're violating copyright of some sort, and then you're only opening yourself to civil litigation. So you can get away with it as long as you're not making any money off of it, because they're not going to. You can't, get blood from a stone. They're not going to sue a company that's not making money. They'll just send a cease and desist letter. Okay. Any questions on this stuff so far? No questions on mine? I don't know what I'm trying to do. There's just a random question on YouTube here. What are you trying to do? I don't know. I'm trying to show you arrays and collections in Java. Okay? Yeah.
Well, we need to use
Oh yeah, assignment 4. Assignment 3 is due this Friday, right? All right. Assignment 3 covers functions, pass by reference, all that stuff. Assignment 4 is on arrays. Assignment 4 will be due in, well, 2.5 weeks, basically. I think, right? Check Canvas to be sure, but arrays will be on the midterm, or maybe on the midterm. I haven't written it yet. But remember that a week from Thursday is the midterm. Okay? So I would, of course, get assignment 3 done this Friday. Another good preparation for the midterm would be to get a good chunk of assignment 4 done. But it's not going to be necessary to complete that, of course, until after the midterm.
So what again is the difference between Java and C with these?
Java has garbage collection. C does not. And everything is manual memory management. C, you have to do bookkeeping. You have to keep track of all the sizes of arrays. Java, you don't because you have that dot length property. In C, you only have arrays, all right? And in Java, you have arrays, sure, but why use them when you've got these beautiful data structures, lists, sets, and maps? Right? Also in Java, because of those things, you have this entire library of methods that you can use and employ. In C, it's way more Spartan. You don't have that much in the standard libraries. You do have a deep copy, by the way. I should have mentioned that. You do have a deep copy. I'll go back up here. Just an honorable mention here. In C, you copy manually, or you can look up and RTM mem CPY. What do you think that stands for? Memory copy, exactly. But you have to really read and understand the documentation on how it works because it's just a raw memory copy. Here's a memory address. I want you to copy X bytes or N bytes from starting at that memory address and copy it over to this memory address, which I am guaranteeing you that I've already set it up properly. It doesn't take care of the allocation for you. You still have to take care of the memory allocation. You still have to do bookkeeping. You still have to clean up after yourself with manual memory management. But there is a function to do at least part of it. Instead of having to do the for loop to copy each thing over, then you can at least just have a one function call. Okay? All right, I will see you on Thursday, where we'll be looking at some additional tooling that will really help you going forward. Now that we've got a substantial amount of material to work with, I can show you how to use a static analyzer tool. I can show you how to use a proper debugger. We don't cover those things at the beginning of the semester because you basically start with hello world code. There's no reason to run a debugger on hello world code. Now that we've got substantial enough, complicated enough, and complex enough code to actually run a debugger on, now is when it's going to start paying off. Okay?